The universe is vast, almost beyond comprehension. It's filled with billions of galaxies, each teeming with stars and planets, each a potential cradle for life. It's hard to imagine something so immense, so full of wonders, could ever come to an end. But what if I told you it will, that the universe in all its grandeur is not eternal? What if I told you that even the universe has a lifespan, a beginning and an inevitable end? This isn't a new idea. Throughout history, humans have gazed at the stars and wondered about the fate of the cosmos. For centuries, humans have pondered the fate of the cosmos, crafting myths and theories to explain the unknown. Today, scientists believe the most likely end is a slow fade into darkness and stillness, a state known as the heat death, where all energy is evenly distributed. It's not the only possibility. There are other theories, each with its own dramatic vision of the end. Some theories propose dramatic endings like a big rip, where the universe tears itself apart, or a big crunch, where it collapses back into a singularity. But heat death, rooted in the fundamental laws of physics, remains the most widely accepted theory among scientists today. So, buckle up, fellow space explorers. Prepare yourselves for a journey through time and space. We're about to embark on a journey to the end of everything we know, to explore the ultimate fate of the universe. To understand how and why the universe, in all its glory, might eventually fade to black, leaving behind a silent, dark expanse. Imagine the universe as a giant engine. It's been running for billions of years, fueled by energy from the Big Bang. But like any engine, it needs fuel to keep going. Here's the catch. The universe's fuel isn't infinite, it's slowly but surely being used up. As it does, the engine sputters. It slows down. Eventually, it will grind to a halt. This is the essence of the heat death theory. It proposes that the universe will continue to expand and cool until it reaches a state of maximum entropy, where no more work can be done, and no more energy is available for use. It's a bleak picture, but it's one painted by our current understanding of physics. To understand why, we need to delve into the concept of entropy. Entropy is a fundamental concept in physics. It's often described as a measure of disorder or randomness, but what does that really mean? Think of a pristine, organized bedroom. Everything is in its place. This is a state of low entropy. Now imagine a tornado ripping through the room, tossing everything about. That's high entropy. Things are more disordered. The second law of thermodynamics states that the entropy of a closed system, like our universe, will always increase over time. It's like a cosmic one-way street. We're always moving from order to chaos. In the universe, this means stars will eventually burn out, galaxies will drift apart, and even black holes will evaporate. Everything will spread out and cool down, leading to a uniform, homogeneous state of maximum entropy. This is the heat death. To truly grasp the heat death, we need to rewind the cosmic clock back to the very beginning. Imagine, if you will, the universe as a newborn star, bursting into existence with the Big Bang. This initial state was incredibly hot and dense, a chaotic soup of energy and particles. But as the universe expanded and cooled, things began to change. Gravity pulled matter together, forming stars and galaxies. Over billions of years, the universe evolved, becoming the complex and wondrous place we observe today. But this evolution comes at a cost. As stars burn through their fuel, they release energy and increase the entropy of the universe. This process, while essential for life as we know it, ultimately contributes to the universe's slow march towards its ultimate fate. Section 5. The clock ticks down, the final stages of the universe. The journey to heat death is a long and drawn-out affair, unfolding over unimaginable stretches of time. The universe, once vibrant and full of energy, slowly transitions into a state of entropy. Over billions and trillions of years, the very fabric of space-time itself begins to change. Let's fast forward through the cosmic eons and witness the key stages. Imagine the galaxies merging, stars being born and dying, and the universe evolving in a grand cosmic dance. 10 to the power of 14 years from now, most stars have exhausted their fuel and died, leaving behind remnants like white dwarfs, neutron stars, and black holes. These stellar remnants are the last beacons of light in an increasingly dark universe. The universe is a much darker and emptier place. The once bright and bustling cosmos is now a shadow of its former self, with only a few faint glimmers of light remaining. 10 to the power of 32 years from now, protons, the building blocks of atoms, begin to decay. This marks the beginning of the end for matter as we know it. Matter itself starts to dissolve, leaving behind a universe dominated by radiation and increasingly dilute particles. The very essence of what makes up the universe is breaking down. 10 to the power of 100 years from now, even black holes have evaporated through Hawking radiation, leaving behind an almost perfectly uniform soup of low-energy particles and radiation. The once mighty black holes, which were the last bastions of structure, are now gone. Entropy is at its maximum. The universe has reached a state where no more useful energy can be extracted from it. The universe has reached heat death. This is the final stage where all processes cease, and the cosmos is in a state of perfect equilibrium. At this point, the universe is a vast, cold, and desolate expanse. The once dynamic and ever-changing universe is now static and unchanging. No new stars can form, no life can exist. The conditions necessary for life and star formation are no longer present. Time loses its meaning because nothing significant will ever happen again. The universe has entered an eternal state of stillness, where the passage of time is irrelevant. Section 6. Are there other endings? Exploring alternative cosmic curtains. While heat death is the most widely accepted theory, it's not the only one. The universe is a vast and mysterious place, and scientists have proposed several other intriguing possibilities for how it might all end. Some alternative theories propose more dramatic endings to the universe. The Big Rip, for instance, is one such theory that has captured the imagination of many cosmologists. This theory suggests that the universe's expansion will accelerate at an ever-increasing rate, driven by a mysterious force that we currently refer to as dark energy. Eventually, this acceleration could become so powerful that it rips apart the very fabric of space-time itself, tearing galaxies, stars, and even atoms to shreds. Imagine a universe where everything is pulled apart at the seams, leaving nothing but isolated particles. Another theory, known as the Big Crunch, proposes a very different fate. Instead of expanding forever, the universe's expansion could eventually reverse. In this scenario, gravity would pull everything back together in a catastrophic collapse, undoing the expansion that has been occurring since the Big Bang. This collapse would culminate in a singularity, a point of infinite density and temperature, much like the state of the universe at the very beginning. However, these theories rely on certain assumptions about the nature of dark energy and the universe's ultimate fate that are still debated. The true nature of dark energy remains one of the biggest mysteries in cosmology. The heat death, grounded in the well-established Second Law of Thermodynamics, which states that entropy, or disorder, always increases, remains the most plausible scenario based on our current understanding. It suggests a universe that slowly fades away into a state of no thermodynamic free energy, where no work can be performed and everything reaches a uniform temperature. Section 7. The persistence of life. Can anything survive the heat death? The prospect of heat death is undeniably bleak, but it also raises a profound question. Could anything even theoretically survive such an event? It seems unlikely. Life as we know it depends on the flow of energy, on the creation and destruction of order. In a universe in equilibrium where no usable energy exists, such processes would be impossible. However, the universe is full of surprises. Perhaps advanced civilizations could find ways to manipulate energy on a quantum level, or even escape to other universes if they exist. While the heat death seems like the ultimate end, it could also be a chance for a new beginning, a cosmic reset button for a universe ready to start anew. Section 8. The universe, a cosmic puzzle we keep trying to solve. The study of the universe's fate is a humbling experience. It reminds us of the vastness of time and space, and our own fleeting existence within it. But it's also an exhilarating reminder of the power of human curiosity. We are a species that yearns to understand the cosmos and our place within it. We build telescopes, launch probes, and develop complex theories to unravel the mysteries of the universe. The more we learn, the more we realize how much more there is to discover. The universe is a cosmic puzzle, and we are just beginning to piece it together. Section 9. What's next for the universe? The heat. Death might seem like a distant and abstract concept, but it has profound implications for our understanding of the universe and our place within it. It challenges us to confront the ultimate fate of everything we know and to ponder the possibility of life beyond our own. As we continue to explore the cosmos and delve deeper into the laws of physics, we may yet uncover new insights that challenge our current understanding of the heat death. Perhaps we'll find that the universe has more surprises in store, or maybe we'll be inspired to find ways to extend the lifespan of our own little corner of the cosmos. The future of the universe is uncertain, but one thing is for sure. The quest to understand it will continue to inspire and challenge us for generations to come.